Now we are at the final phase of this topic. We'll be looking at the last subtopic of this topic, which is solving simultaneous linear and quadratic equation using the graphical method. Wow, I really like this method, and in fact it is to me to what the chemistry scholars call the litmus test, because it has to do with practice and see how it works. This method allows you to follow the steps below. First of all, turn the equation into relations by making a particular variable the subject formula. Most often, the variable y is considered due to the formation of the axis of the graph, where y is considered to be vertical, otherwise dependent on x. Secondly, we have to make a table of values for the formed relations at a given interval, or you chose a range of x for yourself, which most often it will not be given to you. You have to make the choice for yourself. Third, you have to plot the graphs of the table in the same graph sheet. Fourth, locate the points where both graph points intersect each other and mark the point A and B. Final, write down the x and y values of such correspondence. It is as easy as anything, and it's as practical as anything. So let us start with an example. Solve the pair of simultaneous equation using graphical method. Y minus 10 equal to x squared minus 7x and y minus x equal to 3. Solution. Remember our step 1. Make y the subject of the equation in both equations to form relations. So we have the first one as y equal to x squared minus 7x plus 10, and the second one as y equal to 3 plus x. Step 2. Make table of values for each relation taking a considerable range of x, say from 0 to 8. We have initially learned how to plot quadratic graphs and straight line graphs, so I implore you, go back to your notes and learn more if you don't know on how to make table of values. So first of all, you have to make table of value for the first relation, which is y equal to x squared minus 7x plus 10, taking the values of x ranging from 0 to 8 to give you the corresponding values of y. You do the same for the relation y equal to 3 plus x, taking the same range from 0 to 8 and getting the corresponding values of y as seen in the table as displayed. Step 3. Plot the graph of the table of values. You have to make adequate use of your graph sheet to know how to get your scaling, your y-axis and your x-axis. I refer you back to plotting of quadratic graphs. So your graph is what you see on the table. Then step 4, locate the coordinates. That is where the first relation graph cuts the second relation graph, and mark it A and mark the point A and B and locate the coordinate. Here the first coordinate A is s equal to 1 and y equal to 4 as clearly seen, and the second coordinate is s equal to 7 and y equal to 10 as clearly seen. The question in plotting a simultaneous graph is often seen in WAEC, where you'll be given graph sheet an incomplete quadratic table to complete and plot the graph, after which you will be given an equation to still plot the graph of such equation. Let us see from YX standard how it looks. Copy and complete the table of values of the relation y equal to 2x squared minus 7x minus 3. You see we have an incomplete table, x ranging from -2 to 5, using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 unit on the y-axis. Draw the graph of such relation. So you have to make a table of value which is seen here, then you plot the graph as you see it here. Then the question continued to say, by drawing a suitable line, find the values of x for which 2x squared minus 7x minus 5 equal to x plus 4. So what do? We have to compare the relation y equal to 2x squared minus 7x minus 3 with the equation given to us, 2x squared minus 7x minus 5 equal to x plus 4. By so doing, we have to sever. The only difference there is in the relation we have x squared minus 7x and minus 3, but in the equation left hand side we have x squared minus 7x minus 5. So that minus 5 we split it into 2 by bringing out minus 3, it will remain minus 2. So we have x squared minus 7x minus 3 minus 2 equal to x plus 4, which will give us x squared minus 7x minus 3 equal to x plus 4 plus 2. That is, we have carried the minus 2 to cross the equality sign, so each sign changes. So we have x squared minus 7x minus 3 equal to x plus 6. Notice that our left hand side of this equation now is exactly the relation. So if y is equal to 2x squared minus 7x minus 3 and x squared minus 7x minus 3 is equal to x plus 6, it means that y is equal to x plus 6 too. So we can now make a table of value for y equal to x plus 6, which is a straight line, and plot it in the same graph. By so doing, we will have the graph as seen. From the graph, locate the point of intersection, mark A and B, and then read the coordinate. From what I've drawn, my coordinate A is x equal to minus 0.91, where y is equal to 5.08, and my coordinate B has x equal to 4.91, where y is equal to 10.9. So graphical method is way easier for you to see how things are done. View it on a graph and see how things are done. But sometimes if you really want to see if you are correct from what you have done from the graph, you can solve the equation 2x squared minus 7x minus 3 equal to x plus 6, or you can solve x squared minus 7x minus 5 equal to x plus 4, for you to know if really it will give you the solutions we have obtained from the graph. Thank you very much, my dear students. Always continue to keep safe. Always continue to social distance. Wash your hands properly and regularly. Avoid visiting. The best is any person you need to speak with, you call the person on phone. Always try to send empathy and sympathy messages across. Love one another. Very soon we hope to rejoin each other. when the pandemic is less. Thank you very much, and may God bless all of us.